So, hopefully you would have seen from the message that I stuck up that we will be starting a new booklet today. So that is up on Teams for you, on the file section. Sorry, we're already on Teams. So you can download, save, print, whatever you want to do with a copy of that. It is quite a big booklet, so I don't blame you if you don't want to print the thing out. It is going to take us a couple of weeks to crack through all of this one. It is probably the biggest booklet of all of the Coast stuff. But luckily there's some interesting stuff in here that we have to go through. There's some documentaries and some videos and stuff like that that I want you to go through and have a look at as we go through as well. It's a little bit more the funner side of Coast because it's not just talking about the idea of kind of erosion and deposition and the landforms that go along with that. What we need to do with this booklet is look at coastal environments as a whole, so not just the idea of an individual stack or an individual archway or an individual beach. We need to start looking at coastlines in a slightly bigger view. So generally, the big thing that is kind of looked at in this booklet is three dominant coastal environments that we have, and they are what we call aeolian, fluvial, and biotic environments. What we mean by those is an aeolian environment is a wind-blown environment, so an environment that is dominantly there because of the wind. A fluvial environment is one that is river-based and therefore is only able to exist because of the presence of a river, as well as the sea. And then a biotic environment is one that, again, is only there because of the role that plants and animals play in those types of things. So we'll have a little bit of a look at the actual processes for each of those environments, and then have a look at the actual creation of the environment as a whole. So for aeolian or wind-blown environments, we'll have a little bit of a look at sand dunes this morning. For fluvial or river-based environments, we will have a look at mudflats and salt marshes. We'll have a look at those next week. And then for biotic processes, we'll have a look at mangrove swamps and then coral reefs as well. Now, obviously, with these three types of environment, they are coastal. So even though I say that a fluvial environment is one that is river-based, it is a coastal environment under the influence of a river. So it is an environment that you find on the coastline, but there has to be a river involved as well. So it's a river mouth environment most of the time. Now, all of these environments share a few characteristics with each other, and it's the fact that they are quite often the idea of lower energy environments, so where they are sheltered from wave action and they are quite often sheltered from the brunt of the wind. And also they all have something in common in terms of the role that vegetation plays in them. Now, this is where we get a little bit biological on things, but we are still sticking with geography. Vegetation and the ability of vegetation to stabilize environments and make them stronger is something that ties all of these environments together. Now, the further we go through this, the more and more I'll kind of yak on about this sort of stuff. You'll see as we kind of go further through, and as if we do manage to get some field trips going next year and stuff like that, the role of vegetation is what I did my dissertation on. So I end up talking a lot about all of this rubbish as we start to go through. So if I start to bore you, just yell at me and I will change on to a different topic. But before we get into those, we need to kind of put a little bit more detail into the idea of this kind of high and low energy environment aspect that we've been talking about in the last two booklets. Now, this slide we have seen before. I brought it up in the last booklet briefly, But just as a little recap of what we've done, the fact that high energy environments are those ones that are big and exposed to wind and waves and fetch distances, and where we get a lot of the erosional landforms that we've seen so far in the second booklet. So things like headlands, things like wave cut platforms and caves, arches, stacks and stumps, those type of features being formed. And as we mentioned, our low energy environments are those that are sheltered. They are protected from waves. They are protected partially by the wind. And therefore, that is where we start getting things like beaches and spits and the barrier beaches and tombolos that we looked at in the last booklet. Now, one thing that we do have to be aware of with all of this is the idea of scale, because so far we've talked about all of these things relatively locally, because we've been talking about individual landforms as part of a specific coastline, where we have to be aware that high and low energy environments can be localized in that way. They can be regional, and they also can be global at the same time. And it's something that we start to look into a lot, especially as we go further into the course and into next year. Excuse me, the idea of geography at these different scales, the global, the regional, and the local scales of things. So globally, we do get the idea of these kind of areas of higher and lower energy. Now, apologies, the map that I've put up on the board is really blurry. I'll be completely honest, it's because I stole it, and it's quite hard to steal things in really good quality, so we'll just have to make do. It is in the booklet as well if you do end up printing that off. Obviously, I will give you the hard copies of the booklets once we're back properly. But what this map shows, not that you can really read what the key means, is that we do have areas of differing energies around coastlines globally. Now, you'll notice that the outline of all of these land masses, so the coastlines of all of these land masses, have three different colors to them. You have areas which are this kind of slightly green color, so kind of up past Greenland and Iceland and around ourselves as well, over by Alaska, over by Japan and parts of Russia, and also kind of down around the Horn of South America as well. Africa's over there. We then have the darker blue colors, so in and around the Caribbean and California. We have them in and around India and parts of the Middle East, also in and around the Bay of Bengal off the coast of Bangladesh, and down through Southeast Asia and parts of Northern Australia as well. And then finally we have and this one's quite hard to spot, not a really dark blue, but also not a light blue as well. We have a slightly darker shade of blue going up the eastern coast of South America. I'm struggling with me east and west at the moment. Up the eastern coast of South America, and also this kind of eastern side of the South Pacific Islands into Indonesia as well. You'll notice it's a slightly darker blue than the kind of very light blue that runs around the west coasts of places. Now, these dictate the idea of where we get on a global scale these high and low energy environments. Wherever we have the green color, so around Northern Europe and around parts of North America and South America as well, those are what we call storm wave environments. You'll notice that they are what we would refer to as a mid-latitude environment. They're about halfway between the tropics and the poles. That's what we mean by mid-latitude. Now, those storm wave environments are relatively high energy environments. They are areas that receive a lot of storm activity and therefore have a lot of high energy storm waves at the same time. So we in the UK would be, on a global scale, referred to as being in a high energy environment in terms of our coastline. Obviously, if you narrow that down parts of the UK will differ, but as a whole, we are characterized as a higher energy environment. Now, the dark blue, so in and around the Caribbean and California and in and around kind of the subcontinent as well, is the idea of what we call tropical cyclone coastlines. So they, again, are areas that receive very, very high energy waves at times. Whenever they get cyclones or hurricanes, they will end up with the very, very large high energy waves that come with it. So again, a high energy coastline. Now, even though both of those are high energy coastlines globally, what you can say is that areas like ourselves in these storm wave environments are predominantly high energy coastlines. For the majority of the year, we are very, very high energy environments. The tropical cyclone environments, so the darker blue areas, are slightly more sporadic in when they get their high energy. If you think about the Caribbean, most of the time you think about the Caribbean as being a really nice, calm place in terms of the sea. It's only when those big cyclones come in during storm season, so kind of once or twice a year, that those areas end up as incredibly high energy coastlines. So their energy is more sporadic, ours is a little bit more constant. What you then have in terms of that kind of middle blue off the coast of South America and also in and around the kind of South Pacific is what we call an east wells or an east coast swell wave environment. Now, what we mean by that is that these are areas that will get dominantly lower energy in terms of their coastlines, but again, it will be relatively constant. Usually our eastern coastlines globally are relatively well protected. It's because dominantly because of the way that the earth spins and the Coriolis effect, the majority of our winds globally are westerly, and therefore eastern coastlines are usually nice and protected and usually quite well guarded from big waves. If you're sat on the east coast of a big landmass, you are usually going to be slightly more protected from big high energy environments. So that is the kind of picture globally. We do have high energy, we do have low energy environments on a global scale. But as we mentioned, that's obviously not going to be the case. Just because the UK is a high energy environment, that doesn't mean that the whole of the UK is a high energy environment. And if you take it down to a local scale, we actually have a variation in our coastal environments. This little kind of table that is up on the board shows the percentage of wind that comes from certain directions. So the higher the percentage, the more often the wind blows from that particular direction. And you'll notice that the southwest, the west, the northwest, and the southeast are our kind of larger wind directions in terms of percentages, especially the southwest. What it does mean is that for the UK as a whole, our dominant wind direction is coming in from the southwest. Now, as a result of that, if you kind of think about the UK as a whole, if our dominant wind direction is coming up from the southwest, it means that our western and southern coastlines are going to bear the brunt of that wind. So we in South Wales are in a high energy environment for the UK because we face the southwest. Same with South Devon and southern Cornwall, and also the south coast of Ireland out to places like Carmarthen and Pembroke as well. We are all high energy environments within the UK because we face the prevailing wind. If you think about places like East Anglia over on the east coast of the UK, they are nice and sheltered from that prevailing wind. And as you can see from the table, the wind only blows from the east 7% of the time. So they don't get a huge amount of that kind of barrage of wind like we do over in South Wales. So even in the UK, you can kind of draw a line down the middle, and dominantly the western coast of the nations are where the higher energy environments are. The eastern side of the four nations is where the lower energy is, apart from Wales, because Wales doesn't have an eastern coastline. But it does show that even though globally we are a high energy environment, if we break that down regionally, we do have high and low energy environments within the UK, despite the fact that on a global scale, we are a high energy environment. And you can even break it down further again. If you think about the kind of Swansea area we've already mentioned, the south coast of the Gower is a high energy environment, lots of headlands and bays and wave cut platforms. The north coast of the Gower has a big spit and a salt marsh and is a low energy environment. So again, the more you break it down, the more detail you can put into things. Globally, the UK is a high energy environment. Regionally, the UK has high and low energy environments, and South Wales is a high energy environment. But if we go from regional to local, we are in this high energy environment, but we still do have high and low energy environments even around Swansea and the Gower. And it's just important to keep in your mind how that sense of scale will alter things slightly as you go on. Now, the first kind of couple environments that we need to talk about, and the first one that we'll talk about for the majority of today, is one that really does thrive in environments that are actually a little bit of both. Environments that have aspects of high energy, but also aspects of low energy as well. And it's the idea of this creation of sand dunes as a wind-blown aeolian environment. Now, the reason that it needs both is that the creation of a sand dune is technically due to deposition. It is the laying down of sediment into these big, large sand dunes. However, what you do have to keep in mind is that they are wind blown. They do need the wind to be able to form, as well as having an abundance of sand and an abundance of vegetation as well. So they do need that kind of higher energy aspect to them to go along with it. Now, there's a few things that we really need, and these are kind of listed out in the booklet if you have access to it. For sand dunes to form, there are 6 particular things that we need. First one is obviously an abundance of sand. If you don't have an abundance of sand, you're not going to get a sand dune. It's why we don't get sand dunes on shingle beaches, because you need a lot of sand in order for them to work. You also need a low beach gradient, so you need a beach that is relatively flat for them to form. Now, if you think about it, those two things go nicely hand in hand, because we've already talked about in previous booklets that a sandy beach is usually a flat beach. So if you have an abundance of sand, you're going to have a low gradient, because we only really get flat sandy beaches. Another thing that you need is what we call a macro tidal range. Now, macro is a word that some of you may have come across before, especially if you are kind of maths based or economics based or even business based. Macro is the opposite of micro. Micro means small, macro means large. So if we say that we need a macro tidal range, it means that we need a large tidal range, very much like what we've said we have in and around South Wales. There is a very, very big difference between high tide and low tide. That allows big areas of beach to be exposed at low tide, and therefore helps that abundant supply of sand that we need for these to form. You need, fourthly, strong prevailing onshore winds to help sand dune formation. You need winds that blow up the beach from the sea. That way you can get the sand building up at the back of the beach. If you had an offshore wind, it would be blowing all the sand out to sea. And also you need a big area of space for these to form. And it's why, if you think about places where we have large areas of sand dunes around here, so places like Llangennith, just along from Rhossili, and if you think about Oxwich Bay as well, they kind of tick all of the boxes so far. They are big sandy beaches, they are flat, they have a big tidal range, they have onshore winds blowing directly at them, and they have a lot of space in behind them for these sand dunes to be able to form. The final thing is that they do need vegetation. If you don't have the presence of vegetation, and especially things like marram grass and what we call sea couch grass, a sand dune won't fully develop, because they need that vegetation just to stabilize them and help them to grow bigger. And this is where things can get a little bit confusing, but hopefully the two videos that I'm going to point you in the direction of in a second will kind of help this little bit of understanding. So sand dunes are a wind-blown environment, but they do require vegetation for them to develop. You need both of those things. The reason that we call them an aeolian environment is that wind is the deciding factor. Most coastal environments that we're going to look at require vegetation in some way, but it would kind of break the point if we just referred to them all as vegetated environments. So with a sand dune, they need vegetation, but they also need wind, hence why we call them a wind-blown environment. A salt marsh needs vegetation, that's what it is, but it also needs a river, which is why we call it a fluvial environment. Now, your job for today, because I'm going to bring this little bit to an end in a minute and kind of let you lot have a plow on today at your own pace. In the booklet, there is a load of information about the formation of sand dunes themselves. There is the image that you can see up on the screen talking about various parts of the sand dunes. There's also a page of information in there about how they build up over time and the importance of wind and the importance of vegetation to go along with it. Now, what I have also put up for you on our Teams channel for you to have a look at are two videos that kind of go hand in hand with this. The first one that I would like you to have a look at is the one from Time for Geography, the bottom video on the link. Now that is a relatively short video. It's only about 6-7 minutes long. And what it does is talk through the kind of stages of sand dune formation. It's out at Gibraltar Point, which conveniently is actually in Lincolnshire, not Gibraltar. But it talks through kind of how the wind and the vegetation allow this development to take place. Now, from that and the booklet, you should start to have a general idea of what is going on in terms of sand dune formation. And therefore, what I would like you to do is, if you have downloaded the booklet, you can use the booklet to do this, because there is a spare page or a blank page in the booklet for this. If not, just on a bit of paper, I would like you to draw out a diagram similar, excuse me, similar to what you can see on the screen at the moment. Now, with that, what I mean is the idea of small little what we call embryo dunes, building dunes, fixed dunes, and then back to kind of grassland and forest. Now, obviously, the amount of annotation that is around this diagram is huge, and there is a lot of wording in there that you might not particularly be completely comfortable with, especially things like the idea of what we call a rhizome and things like xerophytic characteristics, those sorts of words. So what I would like you to do with the booklet and with that Time for Geography video is to just quickly sketch out an image like you can see, but start annotating it with your own little annotations, what you can put together to explain what this environment is and how it came to be. So how wind actually builds up these sand dunes, how vegetation starts helping that process in terms of the stabilization. Because like we said, these annotations that are up on the screen at the moment are very, very, very big. They are more than what you need and more than what you would be able to remember and pull out in an exam question. So I want you to use this, use the booklet and use the video to come up with a more simplified version of this diagram, one that you would be able to revise from and that you would be able to remember as you kind of go through, like I said, revision and into the exam process. So if a question about sand dune formation came up, it's an image that you could have in your mind annotated of, well, this is the kind of step-by-step stages of how these things come to be. Now, to help out finally with this, the second video, which is actually the first video on the list, is this one. Now, this is the same kind of video series that we've used a couple of times in terms of some of the explanation. Now, in this video, what he actually goes into, if it is the right video, we'll quickly make sure. What he goes into is the idea in a lot more detail about the role of vegetation. No, it's not. Now, the video that I want you to have a look at is this one. Video 3. Coasts, how does vegetation stabilize coastlines? Now, in that video, it is a 20-minute one, he will talk through the role of vegetation in 3 out of the 4 landforms that we need to talk about. He will talk about sand dunes, he will talk about mangroves, and he will talk about the kind of salt marsh and mudflat aspect that we will be going on to over the next couple of weeks as well. So you might find that you want to have a little bit of a watch of that video. So video 3, how vegetation stabilize coastlines. You might want to have a watch of that one before you start putting this diagram together. By the time you've read through the booklet and watched the Time for Geography video, you might be fairly happy to be able to put that diagram together by then. In that case, feel free to have a blast at putting this video together and then have a watch of the Vienna's A-Level Geography channel video just to see if there's any little other bits that you could add on to the diagram. Now, the reason I want you to watch that one last is because it then does tie in to the landforms that we will start looking at next week and beyond. So it does go into the idea of estuary environments with mudflats and salt marshes. It does go into the idea of mangrove forests and mangrove swamps as well, which is the final little bit to go along with this. So that is what I would like you to have a little bit of a blast at today. It's not going to require too much more from me. Have a read through the stuff on sand dunes in the booklet, or bring up the booklet online and have a look through it that way. Have a watch of that Time for Geography video and come up with your own annotated version of what you can see on the screen, but something that is much simpler, something that you understand and that you could recreate if you were asked to. Then have a little bit of a watch of that Vienna's A-level geography video in terms of how vegetation stabilizes coastlines, because that will not only add an extra little bit of detail to sand dunes, but it will also act as a nice little introduction to what we'll be going into next week and beyond in terms of the other environments to go along with this. So, as usual, I will be here if you have any questions, or if you want to check over anything in particular. But this is something really that you will be able to kind of get a grasp of and come up with on your own. So I will be here for any questions, but if there is no questions from you, then that is absolutely fine. Obviously, give yourselves a break at some time. This isn't something that I expect to kind of take up the entire time that we have today. You should be able to plow through this in kind of an hour or so. So you'll have a little bit of time to give yourselves a break if you want to as well. But any questions, let me know. Apart from that, have a good week. Take care of yourselves, and I shall see you next week to be able to go on to the next few steps.